Hydrogen leaks plague the critical Artemis tanking test, but NASA says all test objectives were met. Russia's dictator threatens nuclear war as Soyuz transports a crew with American Frank Rubio to the International Space Station. And NASA belatedly reveals a problem with a key instrument on the Webb telescope, later unveiling spectacular new images of Neptune. All this on today's WSN Space Newscast. A long and sometimes frustrating day for the Artemis launch team and its critical cryogenic tanking test ended around 4:30 p.m. Eastern with a declaration that all of the test objectives were accomplished. The morning started with a slight delay caused by an apparent trespasser inside the blast danger area. A liquid hydrogen inlet temperature sensor failed as the team readied the fast fill operation, but another reading was substituted. Just after 10 a.m., a stop flow of hydrogen was triggered by a leak at the 8-inch quick disconnect seal. Hydrogen readings in the tail service mast umbilical cavity rose to 7%, and the leak was said to have the same signature as the one that scrubbed the last launch attempt. A pre-planned procedure that allowed the line to warm before resuming hydrogen flow was instituted. The pressure ramp was also drastically reduced. On initiation of flow, the leak seemed to stabilize at about 0.5% concentration. Launch Director Charlie Blackwell-Thompson agreed to a new temporary limit of 10% for 5 minutes in the hope of gathering data on the leaky seal. Around noon, the kickstart bleed was instituted, and the leak was reported at over 1%, eventually reaching 3.5%, tracking with the pressure increase. As the fast fill resumed with careful pressure management, the leak actually dropped to 0.5%. This indicated to engineers that the pressure-activated seal was finally performing as designed. Fueling of the upper stage had been postponed while the core stage hydrogen leak troubleshooting was underway. By early afternoon, the ICPS load began. A pre-planned contingency workaround was needed to resolve the loss of boot containment at the upper stage hydrogen disconnect. The final step in the test was the implementation of the so-called core stage pre-press, which will occur at the T-4 40-second mark in the actual countdown. This pressurizes the tanks to flight pressure. The pre-press began at 3:36 p.m., and commentator Daryl Nail quickly reported that a leak of greater than 4% was being detected in the umbilical cavity. The leak was actually not coming from the notorious 8-inch line, but instead from the 4-inch bleed line disconnect. It rose to slightly over 5% and would have been a launch commit criteria violation in a real countdown. Despite the leak, the pre-press itself went smoothly and was accomplished in only 15 minutes, not the hour that had been allocated. A go for cutoff, safing, and tank draining came at 4:30 p.m. Blackwell-Thompson spoke with Nail and gave these comments about the test.
This is Artemis Launch Control at the completion of the Artemis 1 cryogenic demonstration test. I'm Daryl Nail with NASA Communications, and with all of the test objectives met, we have Charlie Blackwell-Thompson with us, the launch director for the Artemis mission. Thanks for being here, Charlie. Charlie just wrapped up comments with her launch team after a long day of testing and a challenging day at times, but overall, a lot of success. I want to get your thoughts, Charlie, on how the test went in your mind.
Well, I think the test went really well. We went into this test, we wanted to learn. We wanted to evaluate the TSMU, the LH2 TSMU under cryogenic conditions, understanding that we had done both an 8-inch and a 4-inch seal removal and replacement out at the pad. And we got into our loading operations. We had a new loading procedure that we had in place. It was very purposeful in the way in which we went through the loading ops. We wanted to be, we called it kinder, gentler, where we really monitored the temperatures and the pressures across the interface. And once we got into what we call our fast fill operations, we did notice as the pressure came up that we did see a leak in the plate cavity at the 8-inch QD. We went through our pre-planned. We have utilized it a couple of times where we stop flow and we allow it to warm up and then we reinitiate. When we reinitiated flow, we began to raise the pressures back up to get back into a fast fill configuration, and we were successful in that. So we did not see the same leak signature, which was wonderful. It allowed us to go through our loading profile all the way to core stage replenish. We also loaded the upper stage today as well, went through our kickstart bleed, went through our pre-press test. So all of the objectives that we set out to do, we were able to accomplish today.
And it was impressive just to watch and take in and listen to the engineers as they work through those leaks. Again, just impressive work. I wonder what your thoughts are on these seals, which, as you mentioned, were replaced. You're learning a lot. There's a lot of data yet to look at. What are your early thoughts about how they're behaving and what a path forward might be?
Well, I think you got to always take the data and go look at what it tells you. One of the pieces of data very encouraging to me was as we raised the pressure, we actually saw the leak go down. And,
on the 8-inch QD.
Yes.
Yep.
And so this is a pressure seal, pressure-assisted seal. So that was very encouraging. And then, we saw the leak rate really taper off. So we'll go take all the data from this event, the early data, the data all the way through loading, through our pre-press tests. The engineers and the team will go take a close look at that and evaluate what we learned today. And then we'll certainly be applying that as we get ready for launch.
The big question is, as you just mentioned, getting ready for launch. What does that mean? And what are the chances for a launch here on the 27th?
Well, I think we'll take the data and we'll go see what it tells us. I am extremely encouraged by the test today, getting through all the objectives, and we're setting up in our scrub turnaround to begin replenishment ops in preparation for our launch day. Like I said, we'll go take a look at the data. I think I don't like to get ahead of the data. And so I'd like the team to have the opportunity to go look at it, to see if there are changes we need to make to our loading procedure, our timelines, or if we're good as is. But I'd like the team to have an opportunity to look at that before I speculate.
And last question on the team itself. As we encountered that first leak, you could kind of feel the room deflate just a little bit. And then as they worked it and got past it, there was a lifting, so to speak, of the room. Talk about kind of what you went through when you were observing this and what you saw your team and how they reacted.
Well, I'm really proud of the team. I think they reacted well. You're going to be disappointed when you see a leak, and I think that's normal. But what they did is they went and looked at what are our contingency procedures, what do we have in place, how do we work our way through it, and they went through those ops just as I would expect them to do, and we were successful in managing our way through it. And you're right, as we began to see that those contingency procedures were successful, certainly there was a lift within the room, but I couldn't be more proud of the team today and the work that they did.
And so now you march on and get that data, take a look at it, and see where it leads us. Charlie Blackwell-Thompson, Launch Director for Artemis.
The Soyuz MS-22 capsule carrying NASA astronaut Frank Rubio and 2 Russian cosmonauts had a successful launch and docking with the International Space Station. Here are highlights of the NASA coverage.
Opportunity to say goodbye one final time to well-wishers at the pad, as well as managers from NASA and Roscosmos, before boarding the elevator at the pad for the ride up to the top of the Soyuz 2.1A booster to board their spacecraft, which they've now been aboard. This in-cabin view showing At the bottom of your screen, Sergei Prokopyev, the Soyuz commander, and at the top of your screen, Dmitry Petelin, Frank Rubio on the right of Prokopyev, out of the field of view here. We are now 50 seconds from launch. And counting. We have engine start.
Umbilical tower separation.
Turbo pumps coming up to flight speed.
Turbo pumps, flight speed,
and liftoff. A sunset start to the mission of Rubio, Prokopyev, and Petelin to the International Space Station.
10 seconds. Flight is nominal.
Good first stage performance reported from the blockhouse at Baikonur, the Soyuz delivering 930,000 pounds of thrust from its 4 boosters and single engine.
L plus 20, L plus 20.
Arcing out to the northeast from the Baikonur Cosmodrome. 35 seconds into the flight. Everything looking good so far. Good roll, pitch, and yaw program. The vehicle reported structural stability is good.
Stable.
Approaching the 1-minute mark into the flight.
Roof is feeling well. Vehicle is nominal. Copy.
Velocity now about 1,100 miles per hour. Yaw, pitch, and roll program all reported to be nominal from the blockhouse at Baikonur.
Nominal. Vehicle is nominal. Crew is feeling well.
Prokopyev reporting the crew is feeling well. Coming up on the 1-minute 20-second mark into the flight. Now passing through the area of maximum dynamic pressure.
L plus 80 parameters are nominal.
One minute 35 seconds into the flight.
Pressure in KPO parameter is above nominal. Copy KZO parameter of nominal. Correct? Affirmative. There's that. Jettison confirmed.
And we've had first stage separation.
Nominal. Crew is feeling well. KZO pressure parameter is nominal. Copy. KZO is nominal. Please report pressure. 8358. 834.
2 minutes 35 seconds into the flight.
Second stage engine operating nominally.
The second stage engine is operating normally. Now a view from the upper stage of the Soyuz booster as it continues to climb uphill.
100.
Launch shroud now has been jettisoned.
Vehicle is nominal.
The Soyuz booster about 48 miles in altitude. Traveling about 5,200 miles an hour. Some 72 miles downrange.
L plus 190.
3 minutes 20 seconds into the flight.
Is nominal. C indication controlled descent available. Vehicle is nominal. Copy. Indication is on.
Well, good reports so far. The flight reported as nominal as we approach the 4-minute mark into the flight.
Pressure reached 105, 1500 for a moment. Copy.
Second stage engine continues to burn as planned as we approach the 4-minute 15-second mark into the flight. About halfway through powered flight now.
Copy.
About 15 seconds away from second stage shutdown and the ignition of the third stage.
L plus 270, parameters are nominal. Second stage separation confirmed.
Second stage shutdown and separation is confirmed. The Soyuz now climbing to orbit on the singular power of its third stage engine. 5 minutes, 12 seconds into the flight, about 3.5 minutes of powered flight remaining.
L plus 310, launch vehicle is stable. Vehicle is nominal, crew is feeling well.
Prokopiev reports that the crew is doing well. This third stage engine providing 67,000 pounds of thrust for the remaining 3 minutes of powered flight.
полет нормальный.
350.
We've now hit the 6-minute mark into the flight, everything going as planned. A true trajectory so far for the Soyuz booster. Now flying on the third stage propulsion of its singular engine. Good roll, pitch, and yaw reported. Good structural stability reported.
секунд, двигатель
380 seconds. The engine of the third phase is working nominally.
стабилизация делия.
400 seconds. The stabilization of the article is in place. It is stable. Altai.
Good structural stability of the Soyuz vehicle at the 7-minute mark into the flight. About 1 minute, 45 seconds of powered flight remaining. Yaw, pitch, and roll all reported to be nominal. At the time of third stage shutdown and spacecraft separation, control of the Soyuz vehicle through docking will transition to the flight control team at the Russian Mission Control Center outside of Moscow. Seven minutes, 30 seconds into the flight. Again, this view from a camera on the upper stage of the Soyuz booster, which should also provide us a view of the solar array deploy shortly after spacecraft separation.
Nominal crew is feeling great.
The crew reported to be feeling great, in the words of Sergei Prokopiev, the Soyuz commander. We have now reached the 8-minute mark into the flight, 45 seconds away from third stage shutdown and spacecraft separation.
480. The parameters of the launcher is nominal, and everything is nominal on orbit, and the crew is feeling great. We're waiting for the separation.
The crew on board the Soyuz MS-22, Rubio, Prokopiev, and Patelin, now about 15 seconds away from third stage shutdown and spacecraft separation.
10 seconds.
$520.
520.
And we have third stage shutdown and spacecraft separation. You see the third stage dropping away. Time tag commands now will deploy the solar arrays and the navigational antennas. Today's journey for Frank Rubio, Sergei Prokopyev, and Dmitry Petelin began at 8:54 and 49 seconds a.m. Central Time, 6:54 and 49 seconds p.m. Baikonur time, just about 7 minutes after sunset in the Central Asian desert, as the engines lit and the Soyuz MS-22 was airborne, climbing out to the northeast from the launch pad at Baikonur. A flawless climb to orbit. Everything worked perfectly for all three stages of the Soyuz rocket as it executed all of its ascent performance activities in good shape. 8 minutes and 45 seconds after launch, the third stage engine shut down, and the Soyuz separated from the third stage, deploying its solar arrays and its navigational antenna for the rest of the flight to the International Space Station.
And velocity is minus 30. We get SR 7.7113, and
as the Soyuz was climbing to orbit, Samantha Cristoforetti, the European Space Agency astronaut on board the International Space Station, who next week will become the Expedition 68 commander, shot a spectacular picture of the plume of the Soyuz MS-22 as it climbed into an orbital sunset, saying, we had a spectacular view. Sergei, Dmitry, and Frank, meaning Prokopyev, Petelin, and Rubio, will come knocking on our door in just a couple of hours. Looking forward to welcoming them. Samantha Cristoforetti has been a stalwart in providing spectacular photos from the International Space Station of activities both on Earth and in orbit throughout the course of her stay on orbit. Of course, Cristoforetti, Kjell Lindgren, Bob Hines, and Jessica Watkins, all part of the Crew 4 Space Crew Dragon crew, will be coming home in early October as they bring to a close almost 6 months in orbit on their own. The occupants of the Soyuz spacecraft, Frank Rubio on your left, Sergei Prokopyev, the Soyuz commander, in the center, and Dmitry Petelin on your right. They boarded their Soyuz vehicle several hours before launch, strapped themselves into their respective seats in the descent module of the Soyuz spacecraft, and settled back for the 8-minute, 45-second ride to orbit, which again went off without a hitch, no problems reported whatsoever. The Soyuz has been executing a series of so-called impulse burns of its engine, essentially in a stair-step fashion, raising its altitude to match that of the International Space Station, which is currently flying over the South Pacific at an altitude of 258 statute miles, about to begin a southwest to northeasterly track that will carry the two vehicles across South America and then back out over the Atlantic Ocean. Soyuz's external television camera of the station, as we are now just about 1 kilometer separating the two vehicles. Soyuz closing at a rate of about 4 meters per second.
Excellent. Range is 1340, range rate -4. Acquisition nominal, 2 numerals 7 visible. 700 range rate -2.3. MRM-1 docking port is visible. Range 130, range rate -0.72. Docking port is off by half a reticle to the left from the center of the VSK. Range 115.
A little over 3 hours following its launch from the Baikonur Cosmodrome, Soyuz now 80 meters away from docking.
'56 final approach, and the target is in the middle. We're expecting the SVP activation.
About 50 meters separating Soyuz from station, passing across the Adriatic Sea.
Inaudible.
This view from Soyuz looking down at the docking port on the Rosviet module.
The LED is on. Inaudible. We copy.
Так, пересветкой можно выбрать лучшее изображение.
Now we
Погода на формате 44.
display illumination is expected any moment, and we are selecting the display. We copy.
Выдал R5. Еще.
R5 command has been
Мишень на одну клетку
the
ниже
hooks
левее
are collected,
центра
and the
войска.
target is to the left by one cell format.
Дальность
Range is
сейчас порядка 10 метров.
inaudible.
Мишень в центре.
The target is in the middle.
Just about 12 meters separating Soyuz from station,
Дальность 7.
Range is
methodically closing towards an impending docking to the International Space Station.
Полклетки правее от центра ВСК.
and the target is about half a cell to the right from VSK display.
Дальность около 4 метров.
Range is about 4 meters.
Полклетки правее
The hooks
от
have
центра
been
ВСК.
collected and the target is a bit to the
Ожидаем
right
касания.
on the VSK. We're expecting contact.
Flight controller standing by for contact and capture.
2.
Range is 2.
Ожидаем касания.
Expecting contact.
Центр мишени левее.
The
Есть.
target is in the center.
Есть.
We've got it.
Касание.
Contact confirmed.
Станция 1.
Capture confirmed.
And we're going
Docking confirmed at 12:06 p.m. Central Time, 1:06 p.m. Eastern Time. Soyuz MS-22 docked to the International Space Station over southern Russia to complete a journey of just over 3 hours in duration.
Finally, on this extraordinary day of space activity, news about the Webb Space Telescope. NASA issued a statement about a problem with one of the 4 observing modes of the telescope, almost 2 weeks after a review board was named to study the issue with the mid-infrared instrument. On August 24th, a mechanism that supports medium-resolution spectroscopy, or MIRI, exhibited what appears to be increased friction during setup for a science observation. This mechanism is a grading wheel that allows scientists to select between short, medium, and longer wavelengths when making observations using the MIRI mode. Following preliminary health checks and investigations into the issue, an anomaly review board was convened September 6 to assess the best path forward. The Webb team has paused in scheduling observations using this particular observing mode while they continue to analyze its behavior and are currently developing strategies to resume MIRI observations as soon as possible. The observatory is in good health, and MIRI's other 3 observing modes, imaging, low-resolution spectroscopy, and corona photography, are operating normally and remain available for science observations. Today, spectacular images of the planet Neptune and its little-known ring system were released. Not only has Webb captured the clearest view of this distant planet's rings in more than 30 years, but its cameras reveal the ice giant in a whole new light. Most striking in Webb's new image is the crisp view of the planet's rings, some of which have not been detected since NASA's Voyager 2 became the first spacecraft to observe Neptune during its flyby in 1989. In addition to several bright narrow rings, the Webb image clearly shows Neptune's fainter dust bands. It has been 3 decades since we last saw these faint dusty rings, and this is the first time we've seen them in the infrared, notes Heidi Hamel, a Neptune system expert and interdisciplinary scientist for Webb. The telescope's extremely stable and precise image quality permits these very faint rings to be detected so close to Neptune. Neptune has fascinated researchers since its discovery in 1846. Located 30 times farther from the Sun than Earth, Neptune orbits in the remote dark region of the outer solar system. At that extreme distance, the Sun is so small and faint that high noon on Neptune is similar to a dim twilight on Earth. This planet is characterized as an ice giant due to the chemical makeup of its interior. Compared to the gas giants, Jupiter and Saturn, Neptune is much richer in elements heavier than hydrogen and helium. This is readily apparent in Neptune's signature blue appearance in Hubble Space Telescope images at visible wavelengths, caused by small amounts of gaseous methane. Webb's near-infrared camera images objects in the near-infrared range from 0.6 to 5 microns, so Neptune does not appear blue to Webb. In fact, the methane gas so strongly absorbs red and infrared light that the planet is quite dark at these near-infrared wavelengths, except where high-altitude clouds are present. Such methane ice clouds are prominent as bright streaks and spots, which reflect sunlight before it is absorbed by methane gas. More subtly, a thin line of brightness circling the planet's equator could be a visual signature of global atmospheric circulation that powers Neptune's winds and storms. The atmosphere descends and warms at the equator, and thus glows at infrared wavelengths more than the surrounding, cooler gases. Neptune's 164-year orbit means its northern pole, at the top of this image, is just out of view for astronomers, but the Webb images hint at an intriguing brightness in that area. A previously known vortex at the southern pole is evident in Webb's view, but for the first time Webb has revealed a continuous band of high-latitude clouds surrounding it. Webb also captured 7 of Neptune's 14 known moons. Dominating this Webb portrait of Neptune is a very bright point of light sporting the signature diffraction spike seen in many of Webb's images, but this is not a star. Rather, this is Neptune's large and unusual moon, Triton. Covered in a frozen sheen of condensed nitrogen, Triton reflects an average of 70% of the sunlight that hits it. It far outshines Neptune in this image because the planet's atmosphere is darkened by methane absorption at these near-infrared wavelengths. Triton orbits Neptune in an unusual backward or retrograde orbit, leading astronomers to speculate that this moon was originally a Kuiper belt object that was gravitationally captured by Neptune. Additional Webb studies of both Triton and Neptune are planned in the coming year. Stocks tanked late Wednesday as traders worried about the hawkish stand of the Federal Reserve. Only 3 of our WSN Space stock watchlist stocks were up. The lucky winners were Momentus, Terran Orbital, and L3 Harris. Losses were rather small, with the worst losers being Astra and Oceaneering. Reporting from cyberspace, this is correspondent Karen Calvis.